Hi everyone, welcome back to our YouTube channel Sid Education. In our today's video, we are going to work on an example of merge sort. So let's get started. Consider we have an array with elements 34, 7, 23, and 32, and we need to sort this array using merge sort. So let's work out on that, and after this we'll see how exactly this algorithm works, right? So what we do, I have already discussed in our previous video that merge sort works on three principles, that is divide, conquer, and merge. So how we divide? We divide, so the division is from the middle. So that is what we consider this as the left, this as the right. So left plus right by 2, and that is the integral value. Okay, because when you have right four elements, 4 by 2 is 2. But when you have odd elements, you can get 2.5, 3.5. So you take an integral value, that is 2.5 will be 2 or 3.5 will be 3, considering your assumptions, right? So that is what we divide. Then we sort and we merge back. So let's see how we do. So here, the simple thing is that what we'll divide it from the middle. That is L plus R by 2 you can put. So you will put 0 plus, if you give indices as 0, 1, 2, and 3. So you will get 0 plus 3 by 2, that is 1.5. I'm considering it as 2. Oh, okay, I'm considering it as from the index 1. That is this, after this index, I will divide it, right? Again, many people consider this as 1, 2, 3, 4. So this is 1 plus 4 divided by 2, and then it is 2.5, which is 2. Again, this becomes 2, after 2 you need to divide. So that is based on what you are assuming, right? So I generally prefer assuming the real index values, because in algorithm we are going to use the real index values, right? So do this, right? That's the best practice. So I'm going to divide from 1. So this get divided into two parts, that is 34 comma 7, and this divided into 23 and 32. Now again keep dividing. You remember I told you when we have to stop. We have to stop when we get a subarray of single element. There we need to stop because we cannot further divide it, right? So again if I divide it, so this will be divided into 34 and this will be divided into 7. Now this will be divided into 23 and this will be divided into 32. Now what we do? So we need to stop here. The divide part is complete because we cannot divide 34 further. There's no possibility, right? So divide work is done. Now we need to conquer. Conquer means what we do, we need to sort this algorithm. So if you see 34 and 7, I know that 7 is less than 34. So if I need to see 7 should come before 34. Here in this case also 23 is less than 32, so no need to do, it is already sorted. Okay, I have done the conquer approach. I have seen which thing is less and which is more. I have sorted those two things. Now you need to merge it. So how you merge it? So once you merge it, you use this thing, conquer thing. So that is you sort it 7 comma 34. Now important is this merging, right? Important is this merging. We'll see how this merging actually happens, right? Now if you merge this, you will get 23 and 32 only. Then what? Again you need to do a merge, right? Because you have not got the solution to the bigger problem. So if you merge, now again you need to sort. So 7, 23, 32, 34. This is what you will get after final merging. Are you getting? So what we do? First we divide, then we conquer, and then we merge. These are the three fundamentals of the merge sort. All right. So now let's go deep into it and see how this merging happens or how this division also happens. We'll see all this, right? So I'm considering this level, it will be easy for me to make you understand, right? Now let's say you have 7 comma 34 as one array and one subarray is 23 comma 32, right? The very first thing what when how we have started with considering a middle element from where we divide. That is what I have told you, left plus right by 2, integral value of left plus right by 2. Okay, so considering that, what we have array from left to right. This is what I have considered. From that I get m as left plus right by 2. So if I consider this as, now this is what? This thing. If you consider this thing is what? This is, do you think it is, if I give this as 0, this as 1, this as 2, this as 3, right? Do you think this is from left to that middle, and this thing is from that middle to right? That is middle plus 1 to right. Are you getting it? So what we need to do, what we are actually doing, we need to merge. We need to merge what? Two subarrays, which is from left to middle, and from middle plus 1 to right. What is our final objective? Our objective is to merge these, right? These two arrays, right? So what we do, we initialize I to left and we initialize j to m plus 1. That is what we are going to do. We will initialize I to this and j to this. Are you getting it? And what we do, we have a temporary array which is b of size n, and there what we do, we initialize k to the index 0, that is to the left, if I wanted to say. So you will have a b array. Okay, so if you have something of 4 elements, so it will be here, k value will be here to the 0 index. Then what we do, we compare a of I and a of j. That is very important. Please be attentive here. I think this is easiest thing, right? What we have done is we need to merge. What we need to merge, I have just technically wrote that. We need to merge left till middle, middle plus 1 to right. Those two chunks I have to merge. And how I merge? I take help of one temporary array. And how this happens, that is what I'm going to talk about here. So what we do now, we compare a of I. What was a of I? This thing, because you have initialized I to the left, right? And what is a of j? That is middle. So you compare 7 and 23. And then you see which is less. And accordingly, you copy that element to this temporary array and increment I and k. That I'll tell you. So what you need to do, you need to compare a of I and a of j. First thing, if a of I is less, right? Then what we do? Then we copy a of I to b of k and increment I and increment k. If I is less than, you copy ai element into b of k and increment I and increment k. Second, else if a of j is less, then we copy what? We copy a of j element to b of k, and what we need to increment? We increment j and increment k. So what you need to remember, that k thing is common. We need to increment k in every pass. But what we need to increment will be decided on which item is less. If a of I is less, we have to increment I. If a of j item is less, we need to increment j. Okay, so let's trace it. So I was talking about, I'll talk about this merge, right? 7 comma 7 34. Okay, then what you have is second two elements. Can you tell me? 23 and 33. 23 and 32. So this is I, this is j. What we do, we check a of I and a of j. So 7 is a of I, a of j is 23. So which is less? 7 is less. So what you do? You have b of k. Okay, k is here at 0. What you do? Copy a of I to b of k. So A of I is 7. You copy 7 here and increment what? Increment I and increment K. In second, now you have A of I is and A of J, again you need to compare. A of I is 34. A of J is 23. So who is less? This is less. If A of J is less, copy A of J. So A of J will be copied, and what you need to increment? Increment J and increment K. Now next, A of I and A of J again compare. If you compare A of J, you get 34 and 32. Which is less? 32, right? So what you need to do? Copy that element A of J to K, B of K, and increment J and increment K. Now you have reached to the bound condition. There is nothing left, right? Then whatever exists in the other part, just copy that. That is 34. In case something is left here and this I is exhausted, then copy exactly what you have. Why? The question is why? Because it was already sorted. This thing was already sorted. See, the sub arrays are already sorted, right? And you have exhausted your limit. For example, here you have exhausted your limit. It means that 32 is there, so the only element left was 34, which is higher, right? If I, let's say, if I have an element here, it would have been 36. There is no possibility that in subarray we had the less element after 34. Do you think? The only element possible is from 34 to infinity here, right? So I have exhausted here, so I could have directly copied 34, 36. Are you understanding? So this is how merge sort works. Let me quickly summarize. Basically what we do, we compare A of I and A of J, and what we initialize I and J, I as the left and J as the m plus 1, and we see which is less. If A of I and A of J, whatever is less, we copy. For example, if A of I is less, we increment I and we increment K. If A of J is less, we increment J, increment K. In case anything get exhausted or completed, we directly copy. We directly copy. As simple as that, right? So in our next video, we are going to again trace back some more examples and we'll see more on the merge sort. So if you like this video, please do like, share and subscribe. Thank you.